Hello my YouTube friends. Today we discuss assembly language program named Write an assembly language program to add two 8-bit BCD numbers and stored at memory location C900H and C901H. Store the result at memory location C902H and onward, starting with least significant bit. So here we trace what in program is asked at two 8-bit BCD number. BCD number are those number which is called as a binary coded decimal number, which is 4-bit number, which is same as a decimal number. Suppose you have 24, then it is called as a 24 in BCD, but it is in hex, it is called as a 24 hex, and in BCD it is called as only 24. That two BCD numbers are added and that are stored. One BCD number is stored at C900H and one is stored at C901H. Then actually what happen, whenever we take a any in 8085 microprocessor, any numbers that numbers are in hex number, so that suppose I will be take here 64H and 46H, but they are BCD, but they are BCD number. But actually what happen, whenever you give a add instruction, then 64H and 46H are considered as hexadecimal number and they are added. Actually what happen, they are added, then it will be produced a hexadecimal addition as AAH. See here, 6 binary is calculated here, 4 binary is calculated, 46 binary calculated, then they are added and we get a hexadecimal addition is AAH. But whenever they are a BCD number or decimal number, then 64H and 46H, they are BCD or decimal number, then its addition is 110 decimal, that is 110 is BCD or decimal number. Actually this concept is asked in program. So I hope you will be understand what a meaning of this program. After discussion of this meaning of BCD number, we discuss now detailed ALP, how it is written. Here MVIB00H, that is move immediate data to B register. That means it will be typed here or it will be right here, because this B register stores carry produced in addition. LXIH C900H means initialize, that is initialize HL, that is load HL with C900H, that means after execution HL is C900H. And whenever move A comma M is executed, then what happen, M is a memory register here and which is addressed by HL, and here HL address is C900H. Whatever data into that memory location, that will be copied to A register. INXH, whenever it is executed, then increment HL address. Here firstly you initialize HL C900H, so that after INXH it is incremented by 1, that is its address is now C901H. And here your second BCD number is stored, so that we add M by add M instruction, that is add M when execute, then content of M register which is addressed by HL and content of A register is added hexadecimally, that is hexadecimal result is produced, that result is stored into A register. Then here most important thing, DAA is give here, because the you asked addition of two BCD number. That means keep in mind, whenever in programming BCD or decimal such words are present, then actually you will be write a DAA instruction. That will be you require DAA instruction because DAA instruction means decimal adjust accumulator. Generally it is used for to addition of BCD or your decimal number, so that DAA whenever used in program, then that DAA immediately write after any add instruction, so that here after add m it will be written DAA because you have add two BCD number, and whenever you have missing that DAA, there is no meaning of writing a program as BCD addition. And whenever you miss that, you will be add only hexadecimal number. So I will be hope why DAA is important here, because we add two BCD numbers, so DAA instruction is must be right here, and whenever you miss, you will be add as hexadecimal number, that is no addition as a BCD number. And after that JNC next instruction is given, that is jump no carry. That means hexadecimal are added, DAA is adjusted in BCD number, and then carry is not produced, then it goes to label next, and if carry is produced then increment B. And after that STA instruction store content of A to C902H, and after that move A comma B, the content of B copy to the A, and STA stores content of A to C900H, and stop HLT instruction is stop. Thus we will be got C902H and C903H a BCD sum, that is BCD result is at C902H and C903H. If carry, then here your carry result is stored, and if no carry, here LSB result is stored. How it is? See by simulator programming. Here I will be displayed here. All things are given. MVIB is clears the B register, HL initialize HL, yeah, move A comma M, give here content of M copy to A, INXH increment HL by 1, I add M, content of A and content of M added and stored to A. DAA must be required because it adds a BCD number, that is adjust your hexadecimal number to the BCD number. And JNC jump pound no carry, and if carry then increment B, and if no carry LSB result is stored to C902H, and if carry then carry content stored to B, that is copy to A and stored to C902H. Here I will be given, suppose I will be given here 67 and 24H, that is that number, and whenever I execute this program, you will be see here C902H addition 67 plus 24 is 91 displayed here. I will be give 64 and 46 in hexadecimal, it will be AAH, but in BCD it is 110H. Then how it is got? Suppose I will be given here 64H. Suppose here I will be given 64H, and again I will be given here 46H. Then your result is 110, that is carry is produced, and so it is displayed in memory location C903H, so that your result is 110. But whenever you miss DAA instruction, suppose I will be miss DAA instruction, I tell that whenever you have missed that instruction, then it is considered as hexadecimal result. See here, I will be execute program, then you will be displayed only hexadecimal addition. So that keep in mind, whenever there is asked such as BCD and decimal, the DAA instruction must be there, and it will be right after any add instruction. I hope you will be understand this program. I will be hope you will be understand this program.